All right, so for this one, we've got a ladder that is resting against a vertical wall. They've got a picture for you that looks literally exactly like this, except their ladder looks like a ladder instead of just a straight line. And we know it's a vertical wall, so we'll put in a right angle. It says that the ladder is sliding down the wall at a constant rate of 2 feet per second. So right off the bat, you should be clued in that this is probably going to be a related rate problem. The ladder is sliding down the wall at a rate of 2 feet per second. So first thing we want to do is label this distance as a variable, y, because the rate, or because that distance is changing, we know its rate of change. And then off to the side, we're going to say that we know that the rate of change of y ought to be -2. The reason it's negative is because it's sliding down the wall, and that means that the value of y is getting smaller. Now, then we'll recognize that it's asking us about this angle here, theta. So we are looking for d theta dt because it says at what rate in radians per second is the acute angle between the bottom of the ladder and the ground changing when the ladder is 9 feet from the base. So that's another thing we need to know. We need to know what this is. Well, we'll call that x. And so the x value that we are interested in is when x is 9. And we know that the ladder is 15 feet. Since the ladder doesn't change length, we can label that hypotenuse as 15. So then all we want to do is we want to somehow relate the theta with the y, because we know the rate of change of y and we're looking for the rate of change of theta. So the easiest way to do that would just be sine theta equals y over 15. So if we do that, then all we need to do is take the derivative of this, both sides of this equation, with respect to t. So the derivative of sine theta ought to be cosine theta, d theta dt, and the derivative of y over 15 ought to be just 1/15 dy dt. And so we're then able to put in our 1/15 here times a -2 for the dy dt, and then d theta dt is still here, but cosine theta we don't know. And so we know that cosine theta is adjacent over hypotenuse. So if we are talking about when x is 9, well, then cosine of theta ought to be 9 over 15. And so we should be able to solve that, multiply by the 15 to cancel the 15s out. And you end up with d theta dt equals -2/9. And ladder problems like this show up, fairly often, not every year. So it's possible you might see something like that. Does that make sense, everyone? Everyone good there? Okay. All right, next one ought to be number 2 from that same test. Let's see here. So we're looking here at this one. I guess I don't need to write the number 2 there. We got f of x is root x plus 3 over root x. We're looking for f prime of 4. So first thing you're going to want to do is rewrite this as f of x is root x plus, in fact, I'll probably write it as x to the 1/2, just to make it easier to look at for my power rule, plus 3x to the -1/2. And then you can just take the derivative using the power rule. So f prime of x ought to be 1/2 x to the -1/2. And this will be -3/2 x to the -3/2. So sorry, -3/2 x to the -3/2. Then we'll go back and rewrite it as 1 over 2 root x, as we drop the x to the denominator because of the negative power on it. And then -3 over 2 times x to the 3/2. And we're going to evaluate that when x is 4. So that ought to be 1 over 2 times 2 minus 3 over 2 times, and then 4 to the 3/2, take the square root first. So that becomes 2 to the 3rd, which is 8, and you've got a 4th, minus 3/16, which looks like that ought to be 4/16 minus 3/16, so we end up with 1/16. Everybody good with that one? Any questions there? All right, next one, same test, 2015, number 23. All right. All right, so we're looking for an equation of a tangent line to the graph of this thing, y equals 3 minus integral -1 to x of e to the negative t cubed dt, when x is -1. So first off, we need to figure out the point, and then second, we need to find the slope. So to find the point, we just plug in -1. So we have 3 minus the integral from -1 to -1 of e to the negative t cubed dt. And we should know that this integral from a to a is just 0. So we end up with -1 comma 3 is the point that we're looking at, which should be pretty evident from all of the answer choices that they gave us anyway. But good to do that. And then second thing we need to do is figure out what y prime is. Well, y prime, the derivative of 3 is 0. And then we have a negative as the coefficient on this. So we're going to end up with a negative, and then the derivative of an integral using the first part of the fundamental theorem of calculus from a constant to x of a function is just that function in terms of x. So we have negative e to the negative x cubed. We need to figure out what that is when x is -1. So -1 cubed is -1, and then a negative in front of that makes it a +1. So we've got negative e to the first, or just negative e. So our equation ought to be y minus 3 equals negative e times x minus -1, or x plus 1. Any questions on that one?
Since the y value is the same for like all of the point slope forms on that one, is it even really worth it to find what y of -1 is?
Yeah, you wouldn't have needed to. I didn't bother to look ahead of time. So yeah, you wouldn't have needed to do that. But good practice for us to do it just in case on the test it wasn't like that. But yeah, you're right.
Makes sense.
Yeah, it doesn't need to. You wouldn't have needed to for this specific one, but in general, yeah.
Thank you.
No problem. All right, cool. Next problem is going to be number 22. Give me 1 second here. I'll be back in just a minute. All right, number 22 from 2015. Here it is. All right, so we've got a function f of x, which is kx over x squared plus 1. K is a constant. We want to know what values of k make f strictly decreasing, so only decreasing, never increasing, on the open interval -1 to 1. So if a function is going to be decreasing, we need to make its derivative negative. So we're going to look for f prime of x. And since it's kx over x squared plus 1, we'll have to use the quotient rule. So that'll be denominator times the derivative of the numerator, which is just k, minus the numerator times the derivative of the denominator, which is 2x, over x squared plus 1 squared. Everybody good with that derivative? Okay. So first thing is we want this to be less than 0 when x is between -1 and 1. So now that we know it needs to be negative, we're going to look at the numerator and the denominator because we need to either have negative over positive or positive over negative. So if we look at the numerator, we'll note that x squared plus 1 is always positive. And if you square it, it's definitely still going to always be positive. So this part is always positive. So what we really need then is just the numerator to be negative. And so what we'll do is we'll factor out the k. So we got k times x squared plus 1 minus, and if I take the k out of the rest of this, it's minus 2x squared. And we want this to be less than 0. So we've got k times, and then here now we've got 1, and we've got a minus x squared, which we want to be less than 0. And if x is between -1 and 1, according to the interval that we're talking about, I take a value between -1 and 1 and square it. When I get that value, it's going to be still between 0 and 1. And so when I do 1 minus that, this will be positive. And so all we need then is for k to be less than 0. And so we'll choose choice A for that. If k is less than 0, that should make f strictly decreasing from -1 to 1. Does everybody feel okay about that? Does that thought process make sense? Why we ignored certain pieces of it and all that? That's good. Josh, that was you. You good with that one?
Yes.
Wonderful. Okay. All right. Next one we've got here is the 2012 test, number 19. All right, so we want the tangent line to this function to have a slope of 1/2. So if the tangent line has a slope of 1/2, that means that the derivative equals 1/2. So we need f prime of x to equal 1/2. And so we'll just first find f prime of x using the quotient rule. So denominator, derivative of numerator, minus numerator, derivative of denominator, over denominator squared. We want that to be 1/2. And let's see. Let's simplify that out to begin with here. So x plus 2 minus x is just going to give us a 2 up in the numerator. So we've got 2 over x plus 2 squared equals 1/2. I'm going to cross multiply to get x. Now I'll write this. I'm going to distribute this out also. X squared plus 4x plus 4, when I multiply that over there and then distribute it out, equals 4. And then we'll subtract the 4 to get x squared plus 4x equals 0. And we'll factor out the x to get x times x plus 4 and see that that happens when x is 0 and when x is 4. And that's it. X equals 0, x equals 4 tells us that it must be choice D, 0, 0, and 4, 2/3. You could plug in 0, 0 to make sure that, that satisfies this equation, and 4, right? 4/6 is 2/3, the same thing. Yeah, and that's that one. Everybody feel good about that one?
Isn't it -4?
Oh, it is -4. Sorry. I should learn to read my own handwriting. Sorry, -4. That's much better. -4 over -2 gives us -4/2. Yeah, that's not a 4. Everybody go with that one now? That I didn't make a stupid arithmetic error.
How'd you go from the 2 over x plus 2 quantity squared to the quadratic equals to 4?
Cross multiplied. So 2 times 2 gives me my 4, and then x plus 2 squared, which is x squared plus 4x plus 4.
Okay, thank you.
Yep. Everybody good there? Everyone's good now? All right, cool. So next one that we've got here, let's see here, where were we? Number 25 from 2015. All right, here we go. Next one. So this one, there's 2 good ways to look at it. So first off, if you plug in 0 to this, you'll get sine of pi over 3 minus sine of pi over 3, which is 0 over 0. So it comes out to be indeterminate, right? So we could just use L'Hopital's rule, or we could recognize that this is the limit definition of the derivative. The limit as h approaches 0 of f of x plus h minus f of x over h, with x equal to pi over 3 and f of x being sine of x. Right? So we have sine of the x value plus h minus sine of the x value, that satisfies the top, all divided by h. So if we recognize that this is the limit definition of the derivative, we can then just say that this is the derivative with respect to x of sine x at x equals pi over 3. And so we would then say that this is just the cosine of x at pi over 3, or the cosine of pi over 3, which we should know that the cosine of pi over 3 is half, right? So that's one way we can do it. The other thing that we could do is, since we knew that it was 0 over 0, we could use L'Hopital's rule. And if we take the derivative of sine of pi over 3 plus h, that becomes the cosine of pi over 3 plus h. And we'll still have our limit in front. The derivative of sine of pi over 3, well, sine of pi over 3 is just a number. So the derivative of a number is just 0. And then the derivative of h is just 1. And as h goes towards 0, this just, again, becomes the cosine of pi over 3. That makes sense to everyone? So 2 different ways you could look at that one. Any questions there? All right. Okay, 2014. Open that one up. And we got numbers 90 and 91 here. Just a second to get down to the calculator section there. All right, here's number 90. So number 90 is asking us, for a particle that moves along a line with this velocity, when is the speed of the particle increasing? So what we're looking for, since this is a calculator question, and I'm going to do it on Desmos since I don't have a way to show a graphing calculator right here, but what we need to do is recognize first off that it's talking about speed. So we're talking about absolute value of velocity. And so we want that to be increasing. Okay. So if the speed is increasing, that means that the derivative of the speed has to be positive. So here's our speed equation. We want the derivative of that to be greater than 0. Okay. But since we're just using a calculator, all we have to really do is just graph the absolute value of the velocity and look at when it's increasing, right? Because we're going to have the graph right in front of us. So I'll throw up the graph on Desmos here real quick. I need somebody to reread that equation back to me. I know it's absolute value. What was it? Negative x cubed, is that right? And then what was the rest of it? Plus 2x squared plus 2 to the negative x. So you'd graph this, and then you'd be just looking for when is this thing increasing. And so you'd note there's a little minimum there at 0.177. And then it's increasing to 1.256. And then it's increasing again from 2.057 to, it looks like, infinity. And so you'd go in and take a look here. It looks like that's choice E. Good or no? Everyone good with that? Great. All right, and then the next one was the one right after that, number 91. 2014. All right, this one's a little bit more in depth. I have to give me a second here to kind of take more than one screenshot of this to be able to see the whole problem. All right. So here for this one, we know, so this is capital F of X is the function. We know that capital F prime is greater than 0. So that means that capital F must be increasing. And we've got F double prime is greater than 0, which means that capital F is concave up. And we got to note that concave up means that the slopes are increasing. Effectively, that's telling us that F prime is increasing. Everybody good with both of those things? I hope. All right, so then we'll look here. Choice A, if F prime is positive, F is increasing. -3, -4, -6, -9, that's decreasing. Nope. -3, 0, 3, 6. Yes, that works. -3, -1, 3, 19. That works. This one works. This one does not work. So we can immediately eliminate A and E. Then we need the slopes to be increasing. So what's the slope between 1 and 2 on this one for choice C? If I go between 1 and 2, the slope is 0 minus -3 over 2 minus 1. It gives us 3. The next slope from 2 to 3 is 3 minus 0 over 3 minus 2, which is also 3. So we'll note that those slopes were not increasing, and the slope stayed the same. It rose by 3 each time. So it couldn't be that one. If we look at this one, the slope is going from 5 minus -3, that's 8, to 11 minus 5, which is 6, to 13 minus 11, which is 2. So those ones are decreasing. These ones stayed the same. This one must be increasing from -3 to -1. That's going up 2 units. Then it goes up 4 units. Then it goes up 16 units. So those slopes are always increasing. So that one should be choice B. Does that make sense to everybody?
Yeah.
Everyone's good there? Yeah? Okay. Cool. Let's see here. Next one. All right. Okay, number 12 from the related, number 12 from the related rates problems. Oh, that's from the, you're talking about from the, I don't know what you're talking about.
The FRQs.
There's related rate FRQs?
Just the rate FRQs.
Oh, just the rate FRQs. Okay, cool. All right, I didn't have that one open. So give me just a second to open up that. What it was number 12, I closed the chat, now I don't see it.
Number 12 of the rate FRQs.
Okay, that's like a storm is washing away sand on a beach or something like that.
Something like that, yeah.
Okay. Cool. All right. So I'll give you guys a second to just look at it real quick for those of you that are just now, read through the first part of it at least. And then I'll give you just a second, and then we'll go through it. Everybody get a chance to read at least the beginning part of it there to know what's happening in the problem?
Yes.
Cool. We got a rate that's, the rate at which the distance between the road and the water is changing because the storm is, washing away the sand or whatever. And then they also give us a derivative of it, which we could have found ourselves, but that's fine. Cool. And they also give us an initial condition, which will be important, that the edge of the water was 35 meters from the road. So we want to know what was the distance between the road and the edge of the water at the end of the storm. Well, that ought to be 35, the initial distance, plus how much it changed from, what was it, 5 hours that it lasted? So 0 to 5 of f of t dt, which I got the scoring guidelines up here. It says that that came out to be 26.495. And that would have been worth 2 points on the AP test. 1 for the correct integral setup. And even if you forgot the plus 35, they'd give you the point for the integral setup. And then the second point was for the actual value. Everybody good with that? Okay. All right. Part B says, using correct units, interpret the value of f prime of 4 in terms of the distance between the road and the edge of the water. So if f is in meters per hour, if we take the derivative of that with respect to t, that should be 1.007 meters per hour squared is our units. And then since this is the derivative of a rate of change, this is how fast the distance, well, yeah, that's good. How fast the distance is increasing. So it's the, it's the rate of change of the distance, which is how fast the distance is increasing. Right? Rate of change of the increase in the distance. Does that make sense to everybody?
Yeah.
Yeah, I should probably put in there how fast the rate of change of distance is increasing. And that was worth 2 points, 1 for the explanation and 1 for the units. All right, cool. I might have to take another break in a second. I got one more kid that's coming over to my house with my kid. I think they might have just shown up, but when I have to take a break, I'll let y'all know. Hopefully it'll be quicker this time. Part C, we're looking at what time during the 5 hours of the storm was the distance between the road and the edge of the water decreasing most rapidly. So that'll happen when the rate of change is equal to 0, right? When the derivative of that is equal to 0. So we're looking for when does f prime equal 0? And your calculator will tell you that that occurs. You just set that equal to 0. That occurs. Hold on 1 second. I'll be right back, everybody. 1 second. The last child that is arriving at my house has arrived, and so I shouldn't have to take any more breaks. Okay, so we're looking for when f prime is 0, and that occurs at t equals 0.66187, and at t equals 2.84038. So then, since we're talking about during the 5 hours of the storm, we need to also be concerned about endpoints as well, since there's an endpoint to that at 0 and at 5. So we'll be checking 0 and 5 as well. And we're talking about when was that rate decreasing most rapidly. So we're looking for a minimum, and we just need to plug in each of these values to x. So f of 0, that one should be easy to come up with. That should be -2. And then the rest of them you'll probably use a calculator for. So f of 0.66187 was -1.39760. F of 2.8, whatever it was, is -2.26963. And f of 5 was -0.48027. And so we just want the one that is the largest negative value, or which the absolute value of it is the largest, and that would be at t equals 8.4038. Everybody good with that? 1 point for setting f prime equal to 0, 1 point for the answer and 1 point for the justification, which is all of these other things came out to be a faster rate than the one at 2.84038. All right. And then for part D, after the storm, a machine pumped sand back onto the beach so that the distance between the road and the edge of the water was growing at a rate of G of P meters per day. P is number of days since pumping. We want an equation with an integral to figure out the number of days that the sand must be pumped to restore the original distance between the road and the edge of the water. So really all we've got to do there is take the integral from 0 to 5 of f of t dt, and that value was a negative value, right? Because the sand was was disappearing, right? And so this is a negative value. And so if we take the opposite of it, that should give us the positive amount that we need to put in. And so then all we have to do is set this equal to an integral from 0 to whatever variable we want to put in here. We won't use t, we'll just use x, since the other equation they gave us was using p. So g of p dp. So that's how much is being put back in per day. We just need the opposite of the amount that disappeared to equal the amount that is put back in. Does that make sense to everybody? That was worth 2 points. One for this integral and should write it this way. One for this integral and 1 for the equation to relate them together. Does that make sense to everybody? Cool. All right, next problem is number 8 from 2015. So, give me a second here to put that into the document. All right, so 8 from 2015. We've got this this nice little differential equation slope field that we've got going here, and we got y equals g of x as the solution, with g of -2 equal to -1. So first thing we want to do is go to where -2, -1 is. That'd be about here probably. And what we need to do is figure out what the limit as x approaches infinity of the solution curve that goes through this is. And so we'll note that this should be coming down like this, and then going up as we go towards infinity. It should be flattening out and going across this line. And so that should tell us that we're approaching this horizontal asymptote of y equals 0. And if we're approaching a horizontal asymptote of y equals 0, that should tell us that that limit should be 0. Everybody good with that one? Right, next one we've got is number 14. All right, so for 14, we're given a graph of f of x from 0 to 4. We want to know which could be the graph of f prime of x. So the first thing we'll look at is, when does f of x decrease and when does f of x increase? So f of x decreases the first half of this, which tells us that f prime must be less than 0 for the first half. And then it tells us that f prime must be greater than 0 for the second half. So if we look at all of our options, A, that does not follow. B, that does not follow. C, it does. D, it does. E, it does not. Okay, so that's just going to leave us with C and D. And then from there, we can look at F has, let's see, F has a low, yeah, so we already got the local max, so that should be fine. If the derivative is, our derivative is increasing here. Let's see, our derivative is increasing, so that means that the second derivative here must always be greater than 0 if f prime is increasing. And here, f prime goes from decreasing, so f double prime goes from less than 0 to f double prime is greater than 0 because it's increasing to f double prime is less than 0 again. So then we just have to figure out which of those makes sense. So it sure looks like we're starting off concave down here, and then it switches to concave up, and then it switches back to concave down. And so we're definitely not always concave up because these pieces at the beginning and the end are concave down. So we can ignore C, and it must be D. Does that make sense to everybody? Any questions on that one? All right. Next one will be number 18, same test here. All right, we got dy dt is negative 10e to the negative t over 2, y of 0 is 20. We want the value of y of 6. So this is just a differential equation. We'll note that there's no y's on the right-hand side of this, which is the variable in the numerator of our differential on the left. So this is not a separable differential equation. We should just be able to integrate this to get y equals, and then we'll integrate negative 10 e to the negative t over 2 dt. And in order to do that, we'll need to do a u substitution. So we'll let u equals negative t over 2, which has du being negative 1/2 dt. We don't have a negative 1/2, we have a negative 10, so we don't need to worry about that. But if we want to put a 1/2 in here, what do we need to do? We need to make this a 20. So we'll have 20 on the outside, an integral of negative 1/2 e to the negative t over 2 dt. Everybody good with that? The 20 times the negative 1/2 still gives us the negative 10 there. And then we should be able to rewrite this as y equals 20 times the integral of e to the u du, which ought to be 20 times e to the u plus some constant, or 20 times e to the t over 2 plus some constant. And then we'll plug in our initial condition that when y is 0, it should equal 20. So if y is 0, this becomes e to the 0, which is 1, plus our constant needs to equal 20. So that only equals 20 if c equals 0. So our integral should be 20 e to the t over 2. We'll evaluate that at t equals 6, which gives us 20.
Wouldn't it be 20 e to the negative t over 2?
Oh, sorry, that's a negative t over 2. Yeah, my mistake. I put that, I was like, there's no 20e cubed. Yeah, that's 20e to the negative t over 2. I just put that in wrong when I did my u sub back in. So 20e to the negative 3 should be our final answer. Make sure when you go back to terms of t or terms of x after u substitution, you write the right thing. Don't write the wrong thing like I just did. Does that one make sense to everybody?
Yeah.
Cool. All right, next one will be number 82 from that same test. Lots of questions from that test, huh? All right, so we got, I didn't get the graph. Let me get the graph. It'd be tough to do this problem without the graph. Cool. All right. First off, I know it says shown above, but it's not above, it's to the right. Okay, so f prime is what's shown here. The line tangent to f prime at x equals 0 is vertical, so telling us right here this is vertical. And we know that f prime is not differentiable at 2, based on the fact that we can see pretty clearly, I think, that that's a cusp. And so then we got to figure out which of those things there that they've got is true. And so whenever we're doing these, we got to make sure that we are careful about what is guaranteed to be true, not just what might look like it's true, especially when you have charts. But we'll just go through here. So first off, f prime does not exist at x equals 2. Well, sure looks like it exists. There's a point there, right? We know that the derivative of f prime doesn't exist at x equals 2. We can say that f double prime does not exist at x equals 2. F prime certainly does, so that we can ignore. F is decreasing on the interval from 2 to 4. Well, f prime from 2 to 4 is positive, which tells us that f is increasing on the interval from 2 to 4. For C, the graph of f has a point of inflection at x equals 2. If it's going to have a point of inflection, that tells us that f double prime needs to change signs, which means that f prime needs to either go from increasing to decreasing or decreasing to increasing. Either way we want to, doesn't matter. So if we look at f prime, it goes from increasing to decreasing at x equals 2. So we're guaranteed that there is a change in the concavity at x equals 2. And so that must be the correct choice. We would see that it's not D, because for D to be true, f double prime would have to change signs, and f prime would have to go from increasing to decreasing or vice versa, which it's not. It's increasing through 0. And then f having a local maximum at x equals 0, that would mean that f prime would go, if it's going to have a maximum, f prime needs to go from positive to negative. And f prime is going from negative to positive at 0, so it actually has a minimum at that value. Everybody good there with 82? All right, next one. Number 20 from 2012. All right, so I did this one in one of the class periods the other day. So we got 2x plus 1 cubed is f of x, and g is the inverse of f. And we know that f of 0 is 1. We want to find g prime of 1. So this is where the inverse rule comes in really handy. We know that f contains the point 0, 1. G contains the point 1, 0. And that's just a thing about inverse functions, right? Switch the x and y values. So then we also know we're looking for g prime of 1. Well, the inverse rule says that if f and g are inverses and you want g prime of 1, it ought to be equal to 1 over f prime, the inverse, at the corresponding x value for f. So 1, 0, 0, 1, we're looking for f prime of 0. We're given f of x, so we'll find f prime of x, which is 3 times 2x plus 1 squared times the derivative of 2x plus 1, which is 2. And so then we will evaluate that at x equals 0, which is going to give us 1 squared times 3 times 2, which is 6. So this should be 1/6. Everybody good with that one? All right. Next one. 2015, number 91. All right, so number 91, we got f prime is cosine of x squared. F of 3 is 7. We want f of 2. So we did a whole assignment on these ones way back last quarter, quarter 2. Or I guess quarter 1 for anybody that's from quarter 1 and 3. Where you can't find the explicit derivative of this. So we can't find the derivative, the antiderivative of this, of cosine of x squared. So we have to use our calculator to evaluate this. And so we're gonna say that f of x ought to equal the integral from some constant to x of cosine of t squared dt plus some other constant. And we should all agree with that. I hope that's just what integration does, right? If we take the derivative of this, we get f prime, and the derivative of the integral from a constant to x of a function is just the function. And then that constant will go away because we're taking the derivative of it. So we have to strategically choose the correct C1 to find our C2. So the C1 we want to use is always going to be the x value that we are given. So what we're going to do is say that f of x is then equal to the integral from 3 to x of cosine of t squared dt plus that other constant. And so that gives us f of 3 is the integral from 3 to 3 of cosine of t squared dt plus the second constant. And the integral from 3 to 3 of cosine t squared dt, this should just become 0. And so since f of 3 is equal to the second constant now, that should equal 7, because f of 3 is 7. So c sub 2 is 7. We now have the function f of x is the integral from 3 to x of cosine t squared dt plus 7. And all we want then is f of 2. So f of 2 ought to be the integral from 3 to 2 of cosine of t squared dt, and then plus 7 after you do the integral. So that's a setup. You don't need to write out all of those steps if you're able to just say, okay, I know the lower limit needs to be 3. That makes the constant 7. You can just go straight to this step if you want to. And so then you'll just plug that into your graphing calculator, and it will tell you what that value is. I don't know offhand what it is. Let's see, Desmos will tell us though. The integral from 3 to 2 of cosine of x squared dx, and we got a plus 7 at the beginning of it. So 6.75859, whatever that is. Looks like that should be choice D. Everybody good with that? Cool. All right, next one we got is 92 from that same test. All right, so 92, we got the graph of h is shown here. And we want to know which of these things has the greatest value. So we're just going to go through and sort of investigate each of these different things and see what we can find out about each one. We're looking for the average value of h on -3 to 2. So the average value of h ought to be 1 over 2 minus -3 times the integral from -3 to 2 of h of x. And so if we think about that, this number out in front is going to be 1/5 of this integral from -3 to 2 of h of x dx. And for now, we're just going to leave it at that. And we'll come back to that in a second. For b, we've got the average rate of change of h from -3 to 2. So the average rate of change is just the slope of h from -3 to 2. So that ought to be the y value at 2, which is 1, minus the y value at -3, which is -2, about, it looks like those are, over 2 minus -3, which ought to give us 3/5. Yeah, everybody good with that? Okay. Next thing is C, the integral from -3 to 2 of h of x. Well, I've got the integral from -3 to 2 of h of x. That's just the area between the x-axis and the curve. Now we're just going to sort of ballpark it here. This and this look like they about cancel each other out. Positive and then a negative, those are about 0. Would you all agree with that? I hope. Okay. And then we can see that this negative area down here is definitely larger than this negative area, or than this positive area is. So this integral is definitely going to come out to be a negative. And so let's revisit part A. If we have a negative, and then we have 1/5 of a negative, right? Those are both going to be less than 3/5, which is positive. Do you all agree with that? I hope. Okay. Great. So that means we can immediately eliminate choices A and C. Then we're going to take a look at choice D, which is the integral from -3 to 0. Well, that -3 to -1, that's clearly a lot more negative area than this little area from -1 to 0 is, or about -3 to -1. And so this is also negative, so we can immediately eliminate that one because this one is positive. And then h prime of 0, well, h prime of 0 is the slope of h of 0. And what's the slope there? It is also negative. So 4 of the 5 of them are negative. The other one didn't even matter if you found the value to be 3/5. We should note that the average rate of change, since overall this goes up, that average rate of change is positive. Does that make sense to everybody?
Yeah.
Wonderful. All right, next one is going to be still 2015. I'm going to look at number 80. All right, so for this one, we have f prime as the graph that's given to us, and we want to know the value of x at which the absolute minimum of f occurs from 0 to 2. So this is f prime, we want the minimum. So first off, we should note that the value here at 1, we're going from the derivative is positive to the derivative is negative, which tells us that the function goes from increasing to decreasing. So the minimum is definitely not going to be at 1, right? That's going to be where we're going to have a maximum. And if it's increasing all the way along from 0 to 1, it's not going to have a minimum at positive 1/2 either. And if it's decreasing all the way from 1 to 2, it's not going to have a minimum at 3/2 because it's going to be lower at 3/2 than it was at 2. So then we just need to determine, where is it lower? Is it lower at 0 or is it lower at 2? Well, this amount of area underneath this curve, if we were to integrate this, is clearly a lot less than this area, since this doesn't even make it to 1, but this does make it down almost to -2, it looks like. And so we are increasing less here, and then we are getting a bunch more negative here. And so our absolute min should be occurring at 2, because the area accumulated between 0 and 1 that's positive is a lot less than the area accumulated between 1 and 2. Does that make sense to everybody? Everyone good there?
So if it was the area was the same, or if the area from 1 to 2 was the area from 0 to 1, and then the area from 0 to 1 was to 1 to 2, would it
Then-
matter if it's negative or positive? Oh, okay.
Yeah, then it would be 0. I mean, if you just flipped, like if you just flipped these around, you mean?
Yeah.
I mean, if the graph looked like this, then this thing would be decreasing all the way along here and then increasing afterwards. So the absolute minimum would actually occur at 1 if those were just straight up flipped. If we flipped it, like if we had, I guess, yeah, I mean, that would actually be at 1. Yeah, if you flip them around like that. Is that what you meant, flipping them that way?
Yeah.
Yeah, then that would be at 1, because this is, now our function is, since the derivative is negative, increasing and then decreasing. Oh, sorry, function is decreasing and then increasing, because derivative is negative, then derivative is positive. So we have our absolute minimum at 1. Does that make sense? Yeah?
How would you know that's the absolute minimum if you still have to check the endpoints?
Well, we wouldn't have to check the endpoints in this case, because I'm, from 0 to 1, I'm always decreasing. So this value at 1 is definitely less than all the other values between 0 and 1. And then it's always increasing after 1 until we get to 2. So the value at 2 is always more than the value at 1 was as well. So you don't need to check the endpoints in that case. Does that make sense or no?
Yeah, thank you.
All right, next one is number.
Actually,
Yeah.
I have one more question. If, say, like the areas was like looked like the same as each other, and like there was, like, what would that? Would you be able to like find an absolute minimum if the areas looked like they were like the same?
Yeah, if there was no way to be guaranteed that this one was larger than this one, like if it was just, if this one just sort of looked about like that, then you wouldn't be able to say for sure.
Okay, so if there's like an answer choice, like there's like no guarantee, blah blah blah, it would be that answer choice?
Correct. Yep.
Okay.
Any other questions on that one? All right. Cool. Next one is 85. All right, so 85, we've got f of x, which is twice differentiable. T of x is the tangent line to the graph of f at x equals 2. And we are being told that t of x, the tangent line, is always greater than or equal to f of x. So this is something we talked about in class the other day about concavity with regards to tangent lines and their functions. So the tangent line is always greater than the function, can only happen, pretend that's a tangent line, can only happen if the function is concave down. if the function is concave up, the tangent line, I should redraw that because that just looks stupid. The tangent line is always going to be less than the function. So this is telling us that the function must be concave down if the value of the tangent line is always greater than or equal to the value of the function. If the function is concave down, that's going to tell us that the function is at 2, the second derivative must be less than or equal to 0. Does that make sense to everybody? And that's in, I talk a fair amount about that in that document that I was telling you guys about, the A/B test reminders document that's in Google Classroom. Yeah, I can explain that again. So what it's telling us is that the tangent line is always greater than or equal to the function. And so the only way for the tangent line to always be greater than or equal to the function is if the function is always concave down. If the function is always concave up, the tangent line will always be less than or equal to the function's value. And so since we need the tangent line to always be greater than or equal to the function, that tells us that our function has to be concave down, which tells us that f double prime must be less than 0. And so we'll pick the value that says f double prime at 2, which is the value we're, as long as it's the tangent line at 2, that's why it needs to be a 2 there. That value must be less than or equal to 0. Does that make sense? Cool. All right, next one, we got number 21 from 2012. All right, so number 21, we got y equals 5 as a horizontal asymptote to which of the following functions? So if y equals 5 is a horizontal asymptote, that tells us that either the limit as x approaches infinity of y is 5, or that the limit as x approaches negative infinity of y is 5. So we can look at each of these, and some of these are easy to tell, like obviously choice B, well, that doesn't have a horizontal asymptote, just a linear equation. Some of them are a little bit more difficult to determine, but if we were to look at all the rational functions first, C, D, and E, we should remember that for a rational function, if the degree of the numerator is less than the degree of the denominator, that should tell us that the horizontal asymptote is 0. And so that would not have a limit of 5 as we went towards infinity or negative infinity. If the degree of the numerator and the degree of the denominator are the same, the horizontal asymptote should be the quotient of the coefficients. So that'd be negative 5, so that doesn't make sense. This one is, again, degree of numerator and degree of denominator are the same, so we'll divide the coefficients. That one comes out to be 5. So that tells us that since this is a rational function, both of these things actually happen to be true. It has a horizontal asymptote of y equals 5 to the right and a horizontal asymptote of y equals 5 to the left. So it should be choice E. And then if we were to look at A, if we were trying to plug in an infinite value to this, the sign of infinity is going towards, and that's just oscillating back and forth between -1 and 1. And so if we take that and divide it by some very, very large number, those values are going to be very, very small. They're going to be very close to 0. And clearly it's not going to be approaching 5. Right? Sine of 5 times infinity is the same as the sine of infinity. So that one doesn't make any sense either. But regardless, it was choice E. Any questions on that one? All right. Next one. Oh, this is the first one from 2013. Give me a second to open that test up. No, what was it? 86, I think. Yeah, 86 from 2013. Give me 1 second here to find that one. All right, so we got f prime is positive, f double prime is negative. So this is telling us that f is increasing, but that f is concave down. And f being concave down means that the derivative, it means that the slopes are decreasing. So we'll just say that. So f is increasing, but it's increasing slower as the x values get larger. So a function that's increasing and concave down looks like this, right? The slopes go from larger values to smaller values, right? When the function increases and is concave down. So first thing we'll check is which functions are increasing, not this one, not this one. The rest of them are all increasing. And then second part is the slopes need to be decreasing. So the intervals are all just 1 unit. So all we need to see is, if the slopes are, if the rate of change of the y values is greater than or less than as we go, or, is it getting larger or getting smaller as we go up? So this one it changes by 1. This one it changes by 1. So the slopes aren't increasing, they're not decreasing, they're staying the same. That's not the case. This one, the slope is going from 1 to 2. Slopes are increasing, so not that one. This one, the slopes are going from 2 to 1. Slopes are decreasing, must be choice D. Does that one make sense to everyone? Everyone's good there? Okay, cool. All right, as of right now, that's the last one from any of those that anybody asked about. Does anybody, oh, never mind, here comes another one. Number 82 from that same test. So we got the derivative of f is x cubed minus 4 sine x squared plus 1. We want to know at which of the following values of x does f have a relative max. So if f has a relative max, that tells us that f must go from increasing to decreasing. If f goes from increasing to decreasing, that tells us that f prime has to go from positive, because that's when f increases, to negative, because that's when f decreases. So we just need to know, when does f prime go from positive to negative on the interval from negative 2.5 to 2.5. And so the easiest way to do that will be to graph f prime. And let's see, we got x cubed minus, what is this, sine 4x squared plus 1. Okay. So then between negative 2.5 to 2.5, we're looking for when does f prime go from positive to negative. Why is my Desmos not showing up? There we go. So negative 2.5 to 2.5. F is going from positive to negative at this point, negative 0.817. And so that's where we'll have a relative max for f, which that's not the value. Cool. Did I type that in wrong? X cubed minus sine of 4x squared plus 1. F prime going from positive to negative.
I think it's 4 sine x squared, not sine 4x squared.
Oh, that'll do it, huh? There we go. Let's try that again. F goes from positive to negative. at 0.542.
You can't see Decimus badge.
There you go. Sorry about that. So yeah, now that I fixed that to 4 sine of x squared instead of sine of 4x squared, going from positive to negative at 0.542, and hopefully that was an answer choice. Looks like it. And you'll note that there are other answer choices. You know, if we looked at these other places, like negative 0.475 is probably on there. 1.396 is probably on there. Those would be relative mins because the derivative is going from negative to positive, negative to positive. Those are two different relative mins, but we want the relative max. So we get that one. All good? Cool. All right, let's see here. Got a couple more. 2014, number 10. All right, here we go. 2014, number 10. So we're given a piecewise defined function, and we want to know for what value of b is this thing continuous at x equals 2. So we should think about what is the definition of continuity. Well, the definition of continuity says 3 things have to be true for a function to be continuous at a point. Number 1, f of 2 needs to exist. Number 2, the limit as x approaches 2 of f of x needs to exist. And 3, 1 needs to equal 2. Those need to equal each other. Right? So first off, does f of 2 exist? Yep, it's b. All right, good there. Next, does the limit as x approaches 2 of f of x exist? So we got x squared minus 7x plus 10 over b times x minus 2. So we're looking at what happens as we approach x equals 2. So we'll note that if we plug in 2 to that, we plug into, we got 4 minus 14 plus 10, which is 0, over b times 0, which is also 0. So this is indeterminate. And so we got to take the derivative of the top and the derivative of the bottom, or we can factor if we want. Doesn't really matter. But if we take the derivative using L'Hopital's rule, the top becomes 2x minus 7, and the denominator becomes b. And so the limit as x approaches 2 ought to be negative 3 over b. So that exists. And we just need to know, when does f of 2 equal negative 3 over b? So when does b equal negative 3 over b? Well, that tells us that b squared equals negative 3. Well, that never happens. So there is no such value of b. So it seems like we should be able to make it continuous because the limit exists and the function exists, but we can't because there's not a way to make those two things equal to each other. Does that make sense to everybody? All right. Cool. Let's see. That was 2000. Okay, I got 2015, number 17. All right. Okay, number 17. Give me 1 second, then we'll start this. My kid's trying to ask me something. I'll be back in just a second. So we have got a velocity of a wave, v of h is 3 root h. H is the depth. And then we want to know the rate of change, meters per second per meter, of the velocity of the wave with respect to the depth of the water. So all we're trying to do here is just take the derivative and then figure out what it is when h is 2. So we're looking for b prime of 2, which ought to be, well, 3 times the derivative of root h, which is 1 over 2 root h. So if you plug in 2 to that, you just get 3 over 2 root 2. Good or no? Any questions on that one? Goodbye, whoever just left. All right. Next one we got is number 18. Same test. We did number 18 earlier. I'm going to skip that one. We did 2015 number 18 earlier in the session. So there should be a video of that one. If you came in late or something, we did that one. All right, number 18 from 2013. All right, so we got a natural log of 2x plus y equals x plus 1, and we're looking for dy dx. So we'll take the derivative of both sides with respect to x, and since we've got both x and y on this side, we'll have to do it implicitly. So 1 over 2x plus y, that's 1 over u, right, times the derivative of u, which is 2 plus dy dx, and then equals 1 on this side as our derivative of x plus 1. So then we're going to clear off this 2x plus y, and we'll just get 2 plus dy dx is equal to 2x plus y when I multiply that to the other side. And then we will subtract 2. 2x plus y minus 2. Does that make sense to everyone? Cool. All right, I think that's the last one that anybody's put in the chat. I think unless I missed some, I don't think I missed anybody. Yeah. Anybody have any other questions about anything? Any of those problems? Anybody else got any more? All right, looks like we got another one. 2014, number 92.
Mr. Bachelor, I meant 2013, not 2014.
Okay, 2013, number 92. Try that again. Maybe if I can find it. All right. So this is the one, right?
Yes, this one.
Okay, cool. Let's see, let's read this here. We got f is defined for all x from a to b, but f does not attain a maximum on a to b. Which of the following must be true? Okay, so the only two theorems we have that involve a function that is just defined, well, not even just defined, but a function that would be, let's say, continuous from a to b, is the extreme value theorem and the intermediate value theorem. Right? So IVT or extreme value theorem. Okay. So first off, the IVT wouldn't have anything to do with it attaining a maximum. The IVT would only tell us that every value between f of a and f of b must exist if it was continuous. this one, the extreme value theorem, tells us that if we have a function that is continuous on a closed interval, we must have a max and a min. So what we're having here is a function that's defined, but doesn't attain a maximum. And so if there is no max, then it is not continuous. Otherwise, it would have to have an absolute max on that interval because of the extreme value theorem. And so right off the bat, we should know that f is not continuous on A to B is the correct choice. Does that make sense?
Yes.
Cool. All right. Let's see.
So is the EVT only for like a max value, or is it also for a min value as well?
It's also for a min, yeah. The extreme value theorem says that if a function is continuous on a closed interval from A to B, that function will attain both a maximum and a minimum on the interval from A to B. That is what the extreme value theorem says.
Okay, thank you.
Yep. Yeah, I just only specifically talked about a maximum here because that's all the problem is talking about. Cool. I think, again, that's the last one anybody's asked for. Anybody have any other questions? All right, I got a couple more here now. 2015. Number 20. All right, everybody, hold on 1 second. I gotta talk to my kid here for a second again. Okay, sorry about that again. My kid's having a bunch of friends over, and I don't know. They're apparently going to walk to the grocery store and buy whatever garbage they want to buy there, which is great because it gets them out of my house. So, number 20, we got y equals b is a horizontal asymptote of this thing. And so we should recognize that this function is a rational function, and this, if y equals b is a horizontal asymptote to it, then that tells us that the leading coefficients, if we distribute this all out to get 2x squared plus whatever over x squared minus whatever, the division of the leading coefficients should be the horizontal asymptote. And so that'd be 2/1 should be our horizontal asymptote. Does that make sense to everybody? Cool. All right. Next one we got is 21. Same text. And I forgot which test that was from. Let's see. 2015. Okay. So 21. All right. We got the base of a solid is this region between the x-axis and square root of 1 minus x squared. And the cross sections perpendicular to the x-axis are squares. We want to find the volume. So first off, we should recognize that this is a semicircle with a radius of 1 on the top of the x-axis. I've mentioned this multiple times this year, that square root of r squared minus x squared is a semicircle. You should know that equation. So then we've got the cross sections perpendicular to the x-axis are squares. And so we are looking for the volume, which means we need to find the area of this cross section, which the area of that cross section ought to be the side length squared. And the side length is just whatever the height of the function is. So the side length is square root of 1 minus x squared. So when we square it, we ought to just get 1 minus x squared. Then the thickness of this is infinitesimally small in the x direction. So we will integrate from -1 to 1, since this is a circle with a radius of 1 minus x squared dx. And that ought to give us x minus x cubed over 3 from -1 to 1, which will be 1 minus a third, minus -1 minus -a third, which is going to give us 2/3 minus -2/3, which is going to give us 4/3. That makes sense to everyone? Everyone good there? So, all right. That is, again, the last one that anybody's asked for. Anybody have any more that they'd like to talk about? Okay. It looks at the moment like a no. So what we're going to do now is I'm going to pull up one of the documents that I have up in Google Classroom. Specifically this one that says exam tips. And I want to talk about some of these things. Even though I know I've talked about them before, I just want to I want to mention them again because a lot of this stuff is important and it's good to hear it right before you take the test. So as far as rounding goes with the calculator sections, do not ever round until your final answer. So if you're going through and finding an x-intercept and need to use that x-intercept value, write out all the decimals and use all of them until you get to your final answer. When you get to your final answer, you can round to 3 decimals. Always round to at least 3 decimals unless they specify otherwise. 3 decimals always. Okay? You can, I think I showed you guys how to store values in your calculator, but if you don't know how to do that, it's pretty straightforward. All you have to do is type in the value that you want to store, and then there is a button that says STO with a little arrow or triangle looking thing. Hit that, and then choose what variable you want. So use the alpha button up in the top left of your calculator, and then pick I think they're green, usually it's like alpha A or alpha B or alpha C. You can basically pick any letter you want, and then it will store it as that value so you don't have to keep typing it over and over again if you don't want to. But don't round till the end. Okay. Important on the free response to not let points at the beginning stop you from getting points later on at the end. So like it says there, if you can do part C without doing it A and B, then do it. That's fine. Okay? And if you can't figure out how to do A and B, don't worry about it. Just do part C and come back to A and B later. And then additionally, if you can't figure out how to do A or B, but you need the answer from it to do something later on in part C or D, make some sort of attempt, even if it's not very good, at trying to figure out what A is so that you can just use that value later on. You probably won't end up getting all of the points for part C or D where you need it, but you can at least get most likely some of the points. Okay. And I've mentioned this quite a few times, but if you are using your calculator to solve an equation, write the equation. So if you were looking for the intersection of x cubed and sine x, write on the paper x cubed equals sine x at, and then you can use your graphing calculator to solve and figure out when they equal each other and write x equals whatever and x equals whatever and however many of them there happen to be, put them all in. As long as you write sine x equals x cubed on your paper, you are good to just write the answers. If you don't write sine x equals x cubed and you just put the values, you're not going to get the answer. You're not going to get the points. Same with if you're using it to find the definite integral, or if you're using it to evaluate the derivative of the function at some x value, write the definite integral out. Write the integral from 0 to 2 of cosine x squared dx. Otherwise, they won't give you most of the points. And I'm sure you guys have seen, as we talk about the scoring guidelines, just having the integral setup is sometimes worth a point. So even if you type it in your calculator incorrectly, you can still get one of the 2 points potentially on that problem. So make sure you write out the integral or write out what you're having the calculator do. I'm going to say this because I've seen people doing this a lot. If you are using your calculator and you need to find the derivative of some function at an x value, just let your calculator do it. Don't try to take the derivative by hand and then try to plug it in. You have a much, much greater chance of making a mistake if you try to take the derivative by hand and then plug in a value, especially on the calculator section, because most of the time on the calculator section, they're going to give you something where the derivative is really painful. If they want you to find f prime of 2, f of x is going to be painful to find by hand. You just need to plug it in and get your value. Does that make sense to everybody? I hope. All right, next one. Please don't erase anything that you've done that you think is bad. If you do something and you think it's completely wrong and horrible and you're very disappointed in yourself and it's awful, leave it there. There might be something within there that might give you a point. Okay? If you're going to skip it and go work on some other stuff, just leave what the garbage that you had there was. Then you can come back later and try and work on it if you want, to try and do something better. And if you're certain that what you've done is better, then just put a big X through the stuff that you thought was terrible from the start. And that's much easier than erasing it. You don't need to worry about erasing it. And then hopefully what you did the second time is better. If what you do the second time isn't better, just put a big X through that and leave the other stuff. And then hopefully you'll get a point or 2 for something. We talked about this too on the FRQs. Don't use your calculator for anything but to graph the functions to see what they look like, to find the derivative at a point, to find the definite integral, or to solve an equation. Okay? Don't use it for maxes and mins, for looking at concavity, points of inflection, when the function increases or decreasing on the FRQs, right? Don't look at the domain and range for it. You can look at them on the calculator to make sure that you did things correctly, but your solution, like it says, your solution must stand alone. The calculus work that you show, right, must sort of stand, right? It shouldn't be that you just use the calculator to figure out where a max and a min is. You should say the max or the min occurred when f prime was 0, which was at these values, and your calculator found those for you. Don't just graph the function and say there's a max here and a max there without any calculus to back it up. Does that make sense? I hope. Okay. Next one is a pretty important one that, make sure you answered the question. So oftentimes it may ask you for the max of a function or the min of a function. If it asks for the max, they want the y value. If they ask for the min, they want the y value. They do not want the x or the x value at which that max or min occurs. You probably need that to figure out what the max or min is, but they want the max or the min. Find the y coordinate. If it just says, where does the max occur, then great. Don't do extra work. Don't go figure out what that max is. Just figure out where it occurs. If the question has any points associated with units, there's a little part of this too here. If there's units in the question, and if there's points associated with those units, it will say indicate units of measure. Okay? If it says indicate units of measure and you don't put the units, you are missing out on points that should be easy. Okay? And if you see something that says indicate units of measure and you have no clue how to do the problem, write some crap that doesn't make any sense if you can't figure out anything better to do, and then put the right units if you know what the units should be. And you should potentially get at least 1 point for the units. So give yourself the best chance of getting that point by putting some nonsense and then get your units. Now this one where it says, after reading a multiple choice question, make an educated guess before skipping it and moving on. If you think it's going to take you a long time to solve a specific multiple choice question, I do suggest skipping it, because a lot of them will take you 30 seconds or a minute to do. And you should be able to just kind of blow through the easy ones. And it's good, make an educated guess, but don't bubble it in on your paper yet. I would just circle it on the paper so that if you get down to a minute left and you got to bubble a couple in, that you just guessed on earlier. You got time to do that. But skip anything that's going to take you more than 2 minutes to complete in the multiple choice. And go find something that's going to take you less time. Every multiple choice question is worth exactly the same number of points. Right? They're all worth 1.2 points. So, do the ones that are going to be quick and easy first, then come back and spend longer on the ones that take longer if you have time for them. And hopefully you'll have time to get back through all of them. But do the quick and easy ones first. Let's see here. Yeah, and that's good advice there too that's written there. So eliminate answers, obviously you guys all know how to take a test, do that. But sometimes plugging the answers back into the problem can really help you. If you plug in the value that you got and it's clearly not the answer, well then figure out what you did wrong, fix it, or at least you can eliminate that as an answer choice if you're running out of time and guess something other than that one that you know didn't work. Does that make sense to everybody? Yeah. Oh, good. When we talk about justifications, make sure that you're specific about your justifications. So like if they're talking about, like it says there, a point of inflection, okay, they want to know that you recognize that in order for there to be a point of inflection, the sign of the second derivative has to change. Not just that the second derivative equals 0 or the second derivative was undefined, but that there was actually a sign change. So use those words. Point of inflection because the sign changed, or the function went from increasing to decreasing because the derivative went from positive to negative. Be specific and clear when you justify things. Okay? Is that good? Yeah, hopefully that's good. Okay, a couple things down here at the bottom. Now note that everything that's written down here is wrong. Don't do these things. Okay? But first off, this is what I was just saying, that if f double prime is 0, then it's a point of inflection. No, that is not necessarily true. The sign has to change of the second derivative, right? And the same with f has a max or min when f prime is 0. No, the sign of the derivative has to change. You have to show using a sign chart, or for the max or min using the second derivative test, that the sign of that first or second derivative changed to give you that point of inflection or the max or min. And also don't forget that you can check when the first and the second derivative are undefined for maxes and mins and for points of inflection. Okay, so that's important too. For some reason, people like to do the average rate of change of a function on a to b as the derivative at a plus the derivative of b at 2. This is not the case. The average rate of change is just the slope between a and b. So find f of a, find f of b, and find the slope between those 2 points. And, number 4 here, the volume by washers, right? It is not subtract the radiuses and then square. It is outer radius squared minus inner radius squared. Okay? And then the next 2 are very important, okay? Especially because the differential equation free response question usually that's the one that has the largest point value associated with it of any of the free response questions. So you want to make sure that you separate the variables on a separable differential equation. You should recognize that a separable differential equation is only going to look, let's see here, I'm just going to pull this back up. I don't know, right? So, right, a separable differential equation will look like dy dx equals something over here with a y in it. You can have x's, you can have y's, right? I don't care what the rest of it is. If there's multiplication and division with a y over here, that is a separable differential equation. And you have to separate the variables. So something like dy dx equals sine x times y is dy over y equals sine x dx. 95% of the differential equations that they will give you on the free response will be separable differential equations. If you don't separate the variables, you will get 0 points for the largest point value problem on the free response questions. So separate the variables. And then when you integrate, don't forget the plus c. If you integrate and forget the plus c, you're going to cut yourself off at about half the possible points on that separable differential equation. You don't want to do that either. So make sure you do the plus c. Make sure you then find the value of that constant. And with that, remember that when you are solving your differential equation, and if in solving that differential equation, you end up having to square root something at the end, remember that that square root can be a plus or a minus. Right? So if you end up with y equals plus or minus the square root of some stuff, don't just assume that it's the positive square root. You have to go back to your initial condition and look and see which one works. So if the initial point was something like 2, -1, the only way to get a -1 out of this is if I take the negative square root of it. But if the point is 2, 1, I need to get a positive value. I need the positive square root. Okay. The same thing applies when you're looking at, like, if you have absolute value of y equals some stuff over here. Make sure that you look at y equals plus or minus whatever it is, and then look back to your initial condition and determine whether the plus or the minus makes more sense. That makes sense to everybody? I hope. All right. Okay. I'm going to talk about these last two here. Don't use the word it, right? If you're, make sure that you are very specific. Don't be general. Don't say it. It's got a max. Well, what's got a max? Does f have a max? Does f prime have a max? Does g have a max? Maybe there's 3 different functions, f, g, and h. And if you say it's got a max, you need to specify which function. So just be very specific. Now, number 9 here, this thing that we like to call universal logarithmic antidifferentiation. You can't do it, right? Remember that if you have 1 over x, the integral of that, yes, is natural log absolute value of x. Right? But if I have 1 over sine x dx, that does not equal natural log absolute value of sine x. Right? It does not equal that. This is a function. I have to have it 1 over u du for it to be natural log absolute value u plus a constant. You can't have a function down there unless you can convert the dx to a du. So just don't do things like that. Okay, don't do something like 1 over x cubed integrated. That does not equal natural log absolute value x cubed. It's not equal to that. This is an integral of x to the -3, which should go up to x to the -2, divide by -2, add your constant. So just be careful with this, okay? I think that should be good there. And then the chain rule, you might see the chain rule come up where they'll give you a composition of functions. So the derivative of f of g of x, you want to know that that's the chain rule. And it's really helpful to just have that memorized, that it's the derivative of the outer function, so f prime, evaluated at the inner function, times the derivative of the inner function. Okay. Or you may see it written out like this: dy dx equals dy du times du dx. So both of those could occur using the chain rule on the AP test. I've seen problems where they will say, they'll give you a value something like y equals 4u, that's not u, 4u plus 2, and u is, let's say something like, let's say like u is equal to 7x. And they'll actually, no, not like that. They'll give you something like, let's say they'll give you y is equal to 2x plus 5, and u is equal to 7x squared minus 1. Okay. And then they'll ask you, what's dy du? Right? Well, you need to recognize that dy dx is dy du times du dx. So dy dx is 2. Du dx is 14x. And so dy du ought to be 2 over 14x, or 1 over 7x. Does that make sense? I've seen those show up in the multiple choice Every once in a while, not that often, but I've seen one or two over the last 7 or 8 years. So just recognize the chain rule in both situations. And that's the last thing on that list, and that's 7 o'clock. Anybody have any other questions about anything?
Do you know what the grade thresholds for like 5 and 4 are?
Good question. So first off, yeah, I don't, because they change from year to year, but I can give you a general idea. And before I do that, I want to I think I said this before in class, but I just want to make sure I reiterate it. Both the multiple choice and the free response are exactly half of the grade. So the multiple choice is worth 54 points. Free response is worth 54 points. Obviously, you guys have seen that all the FRQs are worth 9 points, and there's 6 of them, so that's how you get your 54 there. But there are only 45 multiple choice questions, so they multiply each one by 1.2 to make the total raw score at 54 for the multiple choice. And so the scoring is out of 108. And from the scoring guidelines that I have seen in the past that they don't release every year, generally the cutoff for a 5 is in the low 70s out of 108. So I would safely say that if you get 73 out of 108, you are going to have a 5. That's my best guess. I can't promise that. I mean, you won't know what your score is anyway, because they'll just tell you, that you got a 5. Then they'll tell you what you get. But around a 72, 73, you're pretty safe. I've seen it go as low as like 69 is the cutoff for a 5. And then usually to get down to a 4, it's like anywhere between like 9 to maybe 12 points below that. And then to go down to a 3, it's usually about 10 to maybe even as many as like 16 or 17 points below that. So if you can get, a C minus, a 70% on the test, you probably got a 5. So does that help answer your question? It changes from year to year, so I can't give you an exact number, but that's the ballpark at least.
Yeah, that helps. Thank you.
Sure. Anybody else? Any other questions?